In today's dynamic business environment, innovation is paramount. Companies must constantly evolve to remain competitive. New product development, or NPD, stands as a cornerstone of this evolution. It drives growth and ensures relevance in changing markets. New product development (NPD) is a strategic process that transforms innovative ideas into tangible products with market value. It empowers organizations to systematically move from concept to commercialization, ensuring excellence, agility, and sustainability in product design, execution, market launch, and validation. Let us now proceed with a structured examination of how the new product development (NPD) framework is applied to the development of high-performance bearings for electric vehicles, EVs. In the race toward cleaner mobility, the development of high-performance bearings for electric vehicles, EVs, is mission-critical. EVs demand low-friction, heat-resistant, electrical insulation properties, and extended durability under new operating conditions and maintenance-free bearing systems to support higher speeds, reduce energy losses, and extend motor life. Effective NPD requires creativity, technical expertise, and market understanding. It enables companies to tap into new revenue streams and future-proof their operations. Through a structured new product development (NPD) process, organizations can innovate with precision, from idea to launch, focusing on creating specialized bearings that meet the unique demands of electric vehicles. In this episode of S&P Knowledge Series, let's discuss on the topic S.N. Panigrahi's NPD 9E Copyright Model, a holistic approach for effective new product development, authored by S.N. Panigrahi. The NPD 9E Copyright Model, developed by S.N. Panigrahi, is a structured, step-by-step framework for new product development that transforms ideas into successful market-ready innovations. It navigates through 9 dynamic phases: explore, envision, evaluate, engineer, experiment, execute, establish, examine, and enhance, enabling organizations to innovate with clarity, agility, and excellence. Igniting ideas, driving innovation forward, from exploration to excellence. Each E is a milestone in crafting next-gen products that make a real impact. Let's now discuss the operational mechanisms of the NPD 9E copyright model developed by S.N. Panigrahi, illustrating its application with an example from new product development (NPD) in automotive EV bearings. The 9 E's stands for explore, envision, evaluate, engineer, experiment, execute, establish, examine, and enhance. The automotive industry stands as a prime example of a sector undergoing rapid transformation. The shift towards electric vehicles, or EVs, is reshaping the landscape, demanding new technologies and solutions. The traditional bearings, for example, designed for internal combustion engines, are ill-suited to the unique demands of EVs. These demands include higher speeds, increased temperatures, and the need for minimal noise and vibration. Developing bearings for EVs presents a unique set of challenges. EVs operate at significantly higher speeds than their internal combustion counterparts. This necessitates bearings with exceptional rotational capabilities and resistance to wear and tear. Additionally, the electric motors in EVs generate significant heat. Bearings must be able to withstand these elevated temperatures without compromising performance or lifespan. Furthermore, EVs are lauded for their quiet operation. Bearings must be designed to minimize noise and vibration, ensuring a smooth and silent ride. Meeting these challenges requires a paradigm shift in bearing design and manufacturing. Traditional materials and lubrication methods often fall short. Innovation is paramount, driving the need for new materials, advanced lubrication solutions, and sophisticated manufacturing processes. The development of EV bearings exemplifies the critical role of NPD in responding to evolving industry needs and technological advancements. It underscores the importance of a structured approach to innovation, ensuring that new products not only meet but exceed the demands of a rapidly changing market. Navigating the complexities of NPD requires a structured and comprehensive approach through which organizations can innovate with precision from idea to launch, focusing on creating specialized bearings that meet the unique demands of electric vehicles. The NPD 9E copyright model, developed by SN Panigrahi, provides a proven framework for guiding teams through each stage of the NPD journey. This model emphasizes a holistic perspective, ensuring that all aspects of product development, from ideation to launch and beyond, are carefully considered and executed. The 9E model breaks down the often daunting task of new product development into 9 distinct, manageable phases, each building upon the previous one. The 9 E's of the model: explore, envision, evaluate, engineer, experiment, execute, establish, examine, and enhance, represent a logical progression of activities enabling organizations to innovate with clarity, agility, and excellence. Igniting ideas, driving innovation forward from exploration to excellence. Let's now discuss the operational mechanisms of the NPD 9E copyright model developed by SN Panigrahi, illustrating its application with an example from New Product Development (NPD) in automotive EV bearings. First E. Explore. Discover tomorrow's solutions today. Scan the market, identify unmet needs or customer pain points, industry trends, and emerging technologies and opportunities through comprehensive research. Explore user demands, unmet needs, competitor gaps, and market possibilities through brainstorming sessions and surveys, and generate fresh ideas. Curiosity ignites creation idea generations. Example: R&D explores increased demand for high-speed, low-friction, high-durability bearings in EV motors to reduce energy loss and extend range. Researching how EV motor speeds of 20,000 plus RPM create new bearing requirements that traditional combustion engine bearings cannot satisfy. EV motors produce power efficiently across a wide range of RPMs, unlike internal combustion engines, which need multiple gears to maintain efficiency. The Tesla Model 3, a higher performance EV, is estimated to have a motor capable of reaching up to 27,200 revolutions per minute at a top speed of 162 miles per hour. Hyundai Motor Group's dedicated EVs feature ultra-fast electric motors with a rotation speed of 21,000 revolutions per minute, enabling high performance and driving experience. Second E. Envision. See beyond the horizon, conceptualizing innovative solutions based on discovered opportunities. The team brainstorms and screens the ideas. Create a compelling vision of the ideal product. Maps product features, sustainability goals, and user-centric innovations. Picture the product that powers the future. Example: conceptualizing potential bearing designs and material combinations like ceramic-coated hybrid bearings with specialized coatings to handle both the high speeds and electrical current issues in EV motors with minimal heat generation and zero maintenance. Third E. Evaluate. Measure twice, innovate once. Assess concepts against technical feasibility, cost-benefit analysis, risk assessments, and market potential. Use tools like SWOT, PESTLE analysis, market analysis, risk assessment matrix, cost-benefit analysis, CBA, technology readiness level, TRL, market attractiveness versus competitive positioning matrix, voice of customer, VOC, and stakeholder analysis. Challenge every idea with logic and data. Example: evaluate technical feasibility of the coating process, supply chain readiness, and cost competitiveness of the EV bearing solution. Systematically rating of bearing concepts against performance criteria and manufacturing constraints. Analyze how silicon nitride ball bearings might perform across temperature ranges common in EV operations while meeting cost targets. Silicon nitride, Si3N4, is a ceramic material. It has excellent mechanical properties with exceptional compressive strength and hardness, high rigidity, and wear resistance, making it ideal for withstanding the stresses of high-speed EV motors. Silicon nitride balls are used in full ceramic and hybrid ceramic bearings in applications where ultra-high-speed rotation is required. Silicon nitride balls have an insulating property which is highly effective in preventing electrolytic corrosion. 4th E. Engineer. Precision drives progress. Develop detailed product and process engineering specifications and designs for selected concepts. Design using CAD, simulations, and performance metrics. Turn ideas into intelligent design. Example: creating detailed CAD models and specifications, ceramic and hybrid ceramic bearings, designing the exact dimensions and tolerances for EV motor bearings that optimize both electrical insulation and heat dissipation properties. Engineer bearing prototypes using finite element analysis for thermal expansion and load durability under EV-specific stress cycles. 5th E. Experiment. Test the boundaries of possible. Build and test prototypes under simulated conditions, validate functionality and refine. Apply iterative testing, lab plus field, and tweak based on results. Fail fast. Learn faster, evolve smarter. Example: building prototypes and conducting rigorous testing of ceramic and hybrid ceramic bearings. Experiment with coatings under simulated EV motor conditions. Test for thermal stability, wear and vibration tolerance. Run accelerated life tests on bearing prototypes, simulating 150,000 miles of EV operation while measuring noise, vibration, and electrical resistance properties. 6th E. Execute. Transform vision into reality. Implementing production processes for successful manufacturing. Scale up production and supply chain readiness. Finalize bill of materials, BOM, tooling, vendor contracts, and quality checkpoints. From blueprint to breakthrough. Example: set up specialized manufacturing processes and quality controls. Execute pilot manufacturing run of the EV bearings using precision CNC lines and initiate vendor audits for compliance. Establish precision grinding and coating processes specific to manufacturing ceramic hybrid bearings for EV applications. 7th E. Establish. Build foundations for excellence. Launch product with marketing, sales, and service alignment. Create reliable supply chains and production standards. Developing robust manufacturing processes and supplier networks. Align go-to-market strategy, distribution, and customer onboarding. Anchor your product in the market ecosystem. Example: establish the EV bearing in B2B markets via partnerships with EV OEMs and Tier 1 suppliers, offering performance guarantees. Establish specifications for specialty steel and ceramic materials, supply chains that meet the stringent requirements of EV bearing production. 8th E. Examine. Perfect through perspective. Monitor production and product performance, customer feedback, and market response. Collect and analyze real-world performance data. Use KPIs, customer reviews, warranty data, and field returns to assess. The model promotes a data-driven approach, using feedback from testing and market analysis to inform decision-making at each stage of the process. This iterative and adaptive approach ensures that the final product is not only innovative, but also commercially viable and aligned with customer needs. Review to refine, track to transform. Example: examine post-launch performance. Gather feedback from early EV bearing installations to identify any performance variances between lab testing and actual vehicle operations. 9th E. Enhance. Evolution never ends. Continuously improve the product based on market feedback. Integrate improvements and new features continuously. Use feedback to upgrade designs, materials, and features. Implement iterative improvements to designs and processes. This phase emphasizes the importance of continuous improvement. Products must be constantly monitored and refined post-launch to ensure they remain competitive and relevant in the marketplace. Innovate again, even better than before. Example: enhance the EV bearing with AI-enabled sensors for predictive maintenance, reducing downtime for EV fleet operators. Refining ceramic coating processes based on field data to further extend EV bearing life, for example, from 150,000 to 200,000 miles. This commitment to ongoing optimization is crucial for maximizing the return on investment in NPD and ensuring long-term product success. In conclusion, the NPD 9E copyright model, designed by SN Panigrahi, offers a structured, strategic, and result-oriented framework for new product development, guiding innovations from conception to continuous improvement. It begins with Explore, where market needs and ideas are identified, followed by Envision, which shapes the product concept aligned with customer value. Evaluate rigorously assesses technical, financial, and market feasibility. Engineer translates concepts into detailed designs, while Experiment validates them through testing and prototyping. Execute ensures production and process implementation, and Establish secures market positioning. Post-launch, Examine monitors performance, and Enhance drives continuous refinement. The model ensures innovation with discipline, enabling organizations to deliver high-impact, future-ready products. Hope you liked the presentation. Stay tuned. Like, share, and subscribe for more actionable insights. Join us in the journey of knowledge exchange at S&P Knowledge Series. For more details, contact SN Panigrahi at the below contact details.